Hello and welcome to day 6 of u-Substitution Calc class. Today we are in the u-sub packet. We are all the way on page 9 where it says practice set 3 with a nice pretty butterfly at the top of the page. And your practice problems are going to come from this page. We're going to work through, I think, some of the evens is my plan so that you can go back and try some of the odds on your own. So let's get into it. Number 2 is where we're going to start, the first even one. So that would be a good warm-up for you to try. So before you maybe try it and pause the video and come back to check your work with what I do for number 2, I have a question for you. It's a joke. It's a request. I need help building a set of stairs, guys. Could you give me step-by-step instructions? Steps, stairs. Number 2. Okay, so either give it a try on your own or just come back in and join me on this one. We got to pick you, right? That's always your first step. So let's just slide me this way and we'll get some side work down here. We're going to let u equal. What's it going to be? Can I hear you now? Is it going to be 2x to the 4th or is it going to be x to the 5th minus 1? You've got that 50-50 choice at the top or the bottom. And I think I almost hear you. You're saying x to the 5th minus 1. It's a higher power. And its derivative will be a perfect power for canceling with the 2x to the 4th up top. Its derivative is going to be to the 4th. So that's going to look good. Du dx, the derivative, speaking of which, is 5x to the 4th. Du equals 5x to the 4th dx. And du over 5x to the 4th equals dx. So you've got this and you've got that. This problem is on par with a bunch of the others that we've been trying this week. I think the worksheet's going to get a little more complicated as we go, but maybe not for us. We'll see. Looking back up into the original. So 2x to the 4th, leave that up top. On the bottom, we called this all u, right? X to the 5th plus 1, so we'll make it u down there. And then in for dx, we can plug in du over 5x to the 4th. So it is cool that the 2 and the 5 stay because those won't interfere with our integral, but the x's would have interfered. Those go away pretty conveniently, and you get the integral of 2/5 times 1 over u, or times u to the negative 1, however you want to write it, taken with respect to u. Either way, we know this guy has his own special rule. The function whose derivative is a 1 over x or a 1 over u is going to be the natural log of the absolute value of that. So we've got 2/5. Here's us seeing this rule again, ln of u, absolute value of u, and then plus c. And then leaving our final answer, the finishing touch, x to the 5th plus 1 was our u. X to the 5th plus 1 plus c. Okay, so I hope you feel warmed up. Let's try another. We haven't done as many together. We're going to look at 4 as the next one on this page. We haven't done a lot of them together that are 2 fractional powers, but again, a great example. This will be just like when you go back to do number 1. We'll use the same strategy for 4 as we're going to use for 1, but let u equal. Here's a case where you want to go for an inner part of the function, either this part inside of parentheses or that part. What you don't want to include is the 1/2. You want to leave that there because we can integrate u to the 1/2. We've got a power rule for that. So what are you picking? Left or right? X plus 1 or the squared quadratic? I say go for the quadratic. It's more complicated. It's to a higher power. It's more innermost because it's inside of something being raised to a power, and in a way, its derivative appears. The power of its derivative appears. So let u equal, I'm getting ahead of myself, let u equal just x squared. Let's get rid of that 2 and make it just x squared plus 2x plus 5, the inside of that. Okay, go ahead, do your side work. Take a derivative, solve it for dx. So 2x plus 2. And du equals 2x plus 2 times dx. And du over 2x plus 2 equals dx. Okay, so we need this, and we need that to go into the right spots. Now, go back to the original. What do we have? X plus 1 sitting out there in front. So integral of x plus 1. Luckily, all this stuff is going to be u-Substitution, so u to the 1/2. And in for dx, we have an expression down here. So du over 2x plus 2. And here we sit. We got to decide. We're in trouble unless we can get rid of all the x's. This is not the same as that. Those don't cancel with one another yet, but I'm wondering if you're thinking of something specifically that we can do with the 2x plus 2. Here's where I would love to be with you so I could take your suggestion. But what are you going to do to this to make it look like that? And do I hear you saying factor? We're going to GCF, pull out a 2. I love it. Let's do that. Make it integral of x plus 1, u to the 1/2. I kind of like that written to a fractional power so that we remember when we're integrating what the power is, I guess. And then it's du over 2 times x plus 1. So that and that can cancel. So all we have left are sort of 2 1/2s in a way, right? A 1/2 from that 2 being on the bottom of the fraction, u to the 1/2 power, integral taken with respect to u. So here's the step where we've made it easier on ourselves. We're going to integrate. That means you drop the integral sign in the du, and a plus c is going to appear. So 1/2 plus 1 is 3/2. We want to also, since we're integrating, divide by that 3/2. So make it 2/3 out front plus c. And I'm working on this handwriting. It's not looking very great so far. Let's see if another pen color will help. 1/2 times 2/3 should just be 1. Yep, there it goes with the handwriting again. 1/3. The 2's canceling. In for u, I got to remember what we called u. X squared plus 2x plus 5. And raise it to the 3/2 power plus c. I neglect to mention this a lot, but you can check all of these by taking a derivative. If I were to take a derivative of this, I'd be swinging down the 3/2 power, multiplying it by a third, right, to get a half out front. I would have the 2x, or x squared plus 2x plus 5 to the 1/2 power, but then it would be times an inside derivative of 2x plus 2. This should, if you derive this, you should just get the original back. Okay, let's look at some of the evens. Now it's going to get good. These problems get a little bit spicy, okay? So we're going to look at some of the evens on this side. Secant tangent. We've seen this in some of these problems before too. We got to pick u first. And here, I mean, I feel like problems like these should probably get circled as being a little bit tougher. So we'll circle number 6, so we think a little bit harder about it. And think about our u choices. You've got secant x, tangent x, and you've got 1 plus secant x. You also have the choices of each of these individual things, but I still want to give you the advice. Maybe keep all this together because it kind of goes together, or keep all of this inside stuff together and call it u. Now notice what I just said, inside stuff. We're always looking for inside stuff to be u, so my mind wants me to put 1 plus secant of x. I mean, it would do 2 really good things if this were equal to u. One really good thing it would do would be when we rewrite it, you just have the square root of u, which is very easy to integrate, right? Because we made it 1 plus secant of x. Another great thing is when you take a derivative of what we just wrote, I believe, if I look at my rules, you're going to get the outside back. You're going to get this to cancel. So try that. It was a tougher u choice, but let's try 1 plus secant of x. Its derivative, 1's derivative is nothing. Secant's derivative is what you have outside. It's secant of x, tangent of x, like that. And du equals secant x, tangent x, dx. And we can solve that for dx. Du over secant tangent equals dx. Toughest choice was just figuring out what u should be. And a big deal here is you're not making it just the secant, you're making it everything that was inside of that radical. And we can plug back in now. So we go back up to the original and hope that things will cancel here. You have integral of secant x tangent x, that's what we're hoping will go away. Square root of something nice, just u, that's good news. And then for dx, I have very little room, but it's going to be du over, secant x tangent x. That is awesome. The secant x tangent x on top and bottom can cancel, all of it, and all you're integrating is something quick, square root of u with respect to u. And in the last problem, it went a little better when we thought of it as the 1/2 power. So we've done this before. U is going to be raised up to the 3/2 as long as you divide by 3/2. So we'll multiply by 2/3 by the reciprocal plus c. And then last step, plug back in from your original substitution. So we'll make it 2/3, 1 plus secant of x to the 3/2 plus c. And that one is finished. Okay, I see some good ones coming up. Number 8. 8 gets circled and starred. 8 we want to take nice and slow and have some discussion together before we just jump into anything. You have 2 different trig functions, and it's hard to choose between them because they kind of are each other's derivatives in a way, right? Cosine's derivative is negative sine, sine's derivative is cosine. So one isn't really more complex than the other, and they are both each other's derivatives. So what was that other suggestion of making a U choice? More complex, derivative appears. What about innermost? Innermost is the key here. If I look at this, by trig notation, this is that cosine to the 4th x is just like saying cosine of x raised to the 4th power, sine of x. I say that helps me pick U because I see cosine as more inner than sine is. It's being raised to a power. So it's a 50-50 choice. I would not include the power, kind of like 2 problems ago when we didn't include the 1/2 power in our substitution. And if I have to make a guess, if I have to choose between sine and cosine, I'm going to go for the one that's inside of parentheses being raised to the 4th. So let U equal cosine of x without the power. Now we derive carefully. So du dx, take a derivative, equals negative sine of x. And du equals negative sine of x dx. And we can divide du over negative sine of x equals dx. Okay, I hope this does the trick. We've got these 2 puzzle pieces to plug back in, and we'll go to the version that we changed. So this version right here. We want to integrate u to the 4th. Well, that doesn't scare me. That's not going to be bad. Sine of x needs to go, and as soon as we do this substitution in for dx, it's going to go. Du over negative sine of x. Perfect. We can get rid of the signs. So long. Top and bottom. The negative remains. You're integrating negative u to the 4th, du. This is the gratifying part for me. I don't know about you. When you take something that just looks so crazy at first glance, and this is the toughest page that we've gotten to so far. Wait till tomorrow. You'll see some tougher ones. But we're going to try to integrate. So negative. Take u up to the 5th and divide by 5 plus c. And then in for u, we can plug in what u equals. So u equals, what was it? Cosine of x. So cosine of x to the 5th. Or you can write cosine to the 5th x plus c. Okay, choices, choices. We are kind of continuing down these evens, so if you want to, the last trig one has secant squared of 3x in it. This is very different from the other ones we've seen too because it's got 3 levels. It's got, and I'll write it this way so you can see it a little clearer. It's got the secant of 3x, and it's all to the 2nd power. That's how the notation should be. So one level is squaring, that's the outermost. The next innermost level is the secant part, and the inner of the inner is going to be 3x. For this one, we're kind of lucky because secant squared is a derivative that we have on this list. And also, at least we don't have some other trig function bogging us down where we have to make a choice between the 2 when we're picking u. I say the innermost part of the function, either way you slice it, is the 3x. 3x should do the trick because secant squared doesn't really scare me off in terms of a derivative. Let's let u equal the innermost part of the function, the 3x. And du dx should be real quick, just a 3. Du equals 3 dx, and du over 3 equals dx. Okay, so keep these things in mind as we sub back in. I'm going to sub into this version, and we'll make it secant of u squared. Secant of u squared dx. Now we got to think for a second. Does this appear on our list of trig antiderivatives? And it actually does. I'm going to go back to the other notation that was given originally. It's the secant squared of u. That's the exact same thing. If I look at my list, there is a function that has that as its derivative, and that function is tangent. Tangent's going to do the trick here. That's tangent of u plus c, and that is tangent of 3x plus c. So here was a case where the innermost part of the function helped us out. I hope you have a great day. Thanks for tuning in. Until next time, see you later.